Alright, time for another draftphysics.com, debatephysics.com also, video presentation. Yes, it's the big event. Yeah, big. Anyway, the email event in the defense of good science, to promote good science, to defend the idea that science should actually prove what they say when possible. I mean, there's some things they can't prove, but this whole argument between kinetic energy and 1/2 mv squared, well, it's momentum versus kinetic energy. Simple enough. I still screwed it up somehow. Anyway, yeah, there's a ton of experiments to try to get to this fact that somehow, what does energy mean in the universe? I'm arguing that it means that whenever you're moving matter in the universe, that requires the consumption, the use of something called energy. That once it has motion, it can give motion to other things. It can exchange the motion. It can't make more motion. It can just exchange the motion it has captured. And their theory is that somehow if you change the velocity, you make more energy. And I'm just saying that's just not possible, that the physical universe is in quanta chunks. No matter how you look at it, it's in chunks. And you have to have chunks to move, and there's just no way you can make more chunks. To go faster, you need more force, and it's just that simple. You can't use 5 times the force and make 25 times the energy. You can't do it. So momentum is the only thing that's real, and kinetic energy is just some notion that has to do with the fact that, yes, if you apply energy over a smaller surface area, it can do more damage to a surface. And if you apply it in a shorter amount of time, it can also cause trouble. So the classic example would be in applying heat to glass, for example. If I apply a bunch of heat to one little section of glass, the glass will shatter. If I apply the heat over the whole surface of the glass will be just fine. So there's lots of examples where pressure crushes something, and if I try to crush the whole thing, I don't get anywhere. Like an egg, I can try to crush an egg and it just doesn't work. But if I apply just a little tiny bit of pressure in one location, yes, it breaks fairly easily. So that doesn't mean that there's more energy. It just means that, yes, you can apply energy differently and get a different outcome, but it doesn't require more energy. An explosive, for example, only has a certain amount of energy. You can't put lighter things in front of it and create more energy, and put heavy things in front of it and create less energy. That can't happen. It'll always produce essentially the same amount of momentum in objects. So if you put a heavy object, you'll end up with the same momentum. Like, for example, the bullet in the gun. The recoiling gun is 1,000 times heavier. It goes 1,000 times slower. The bullet's 1,000 times lighter. It goes 1,000 times faster. Same amount of MV, same amount of force and power and work and energy and all of, however you want to look at it. And so the two are really equal. Now, yes, the bullet's more dramatic in how it releases its energy, but that's all it is. It's just drama. It's not real. It's not substance. It's just the fact that applying energy quickly and on a tiny location is a very effective way to break something. But it's not more energy. And it's really important to get that definition right. So anyway, this little web page has the details, essentially, for sending an email asking physicists to have the tools to basically, try to do some of these experiments to clarify the existence of this 1/2 mv squared. Show me it being collected. Show me it being created. Show me it working. Now, the second part of this, there's two aspects, two claims made by most of physics anyway. Well, anyway, let's just finish this little bit on the, okay, so there's all the the 6 or 7 websites to send the email to, and you just copy and paste that into your to section, and then there's a subject. You just grab that, and then there's this description of what we're pleading for and why, and you just send the email, and I'd appreciate that. And just encourage physics to do these experiments, because they really haven't. The only one we have is like an accidental experiment that the Mythbusters did, where they actually crashed cars. So they actually took 2 cars, identical cars, and just for the drama effect of it, they were trying to prove something about how 2 50-mile-an-hour crashes don't equal 1 100-mile-an-hour crash, and they didn't even prove it very well. But anyway, they didn't prove it, frankly. What they were trying to do was wrong anyway, which was kind of ironic, because it was really bad physics, frankly. I mean, it's sort of important. I mean, they were basically claiming that and it gets to the subject in some respects. I mean, because it's just so kind of ignorant, and you're saying physics, they should be able to do a lot better than this. So they have a 50-mile-an-hour car, and a 50-mile-an-hour car crashed, and the claim is that it's just a 50-mile-an-hour crash. And that's only true because you have 2 crushable cars, so it's like having 2 springs hit each other. And so you're spreading the whole crash over 2 springs. And if you put 1 spring in here, okay, then the 1 spring is going to say, no, that's why it's a 100-mile-an-hour interaction. So if you have 1 spring between the 2 cars, then it's going to read 100-mile-an-hour kind of compression. And yes, if you have 2 separate springs banging into each other, then it's going to read like a 50-mile-an-hour crash. So that doesn't take rocket science intelligence to understand. But anyway, so that's what they were doing. And, so they did the crash of 50 miles an hour into a brick wall and 100 miles an hour into a brick wall. And it was clearly just 2 to 1 in terms of how much the cars were crushed. So the car going twice the speed should have, been 4 times the amount of damage, in the sense of, for the same car going twice the speed should have 4 times the damage, and it's only twice the damage, and clearly in the experiment. And so we've talked about over the years all these other experiments where you roll something and you got to prove that what you're rolling has, a possible experiment would be some way to figure out how much friction goes into the ground when you just roll something and let it come to a stop. So it comes to a stop. So all the energy is absorbed by the ground. And, a simple test would be to see how hot the ground got or something. And, prove that something going twice as fast is going to put 4 times the amount of energy into the ground. Or something going 5 times as fast is going to put 25 times the energy into the ground. So I have detailed lots of experiments in videos that are linked in the thing, so that should be good enough to encourage somebody to think of good experiments to do. But this all goes back, way back to 350 years ago when von Leibniz, yeah, right, proposed, stated as it just being a fact, that, and a lot of people believed it. They didn't really think about it. They didn't have any good way to test it 350 years ago. And so somebody could make the statement, and most physicists believed it, that 4 pounds dropped 1 foot was the same as 1 pound dropped 4 feet in terms of the impact it would create when it hit the ground. Their argument being is that this is 4 units of gravity. Now, the simple counter argument is that Galileo and Newton, I think, would not have fallen for that, because they understood gravity to be a time-dependent force. It's how long you're in the gravity will decide how much work gravity does on you, giving you motion. And the truth is that this action here, is the same as this action here in terms of the time. It's 1 unit of time. And that this whole part here is just 1 unit of time in the gravity. So it's only going to fall for 2 seconds. So if the first one fell for 1 second, the second one's only going to fall for 2 seconds, not 4 seconds. So it can't have 4 times the energy because it's only in the gravity twice as long. And it's really just benefiting from the fact that in the second unit of time, 2 units of distance will be for free because it's already moving that velocity. It doesn't need any more energy to keep going that distance. And it just acquires 1 more unit of extra 9.8 meters per second. Obviously, it's 9.8 meters per second. Another basic, simple argument saying, why are they arguing for something else when it states overtly it's 9.8 meters per second of extra velocity per 1 second? It's in 1 second units. 2 seconds is only 2 units. You only get twice the velocity. Twice the velocity is not going to be 4 times the energy. So it goes all the way back to that and the fact that they never did that experiment. So they've never demonstrated those to be equal. And the simple truth is, as I demonstrated on my porch, and obviously I didn't do anything unique or spectacular. This is something they've known for thousands of years. That if I do the same experiment, I put a 4 mass 1 distance, and I put a 1 mass 4 distances. Okay, that's a 1 mass. Well, I really do have to, have to use all of the board. I just gotta get used to that. Well, that's not all of it either. Okay, that's a little better. Alright, so the milliliter, here's the 4 mass, and here's the 1 mass. Okay, 4 units of distance. Alright, and the fact is this will oscillate. So here's the fulcrum. So if you make this device, it'll oscillate hundreds of times with this going 4v, okay, and this going 1 velocity. So the 4 mass, okay, going 1 velocity is the same as a 1 mass going 4 velocity. And that's, it's it's a reliable device. It tells you weights. It does the job for you. And you could use it the other way around. You could make a traditional fulcrum type weight, and you could just put this 4 pound here and then just use your own, just press on the same spot over on this other side, and these two things will weigh the same. It'll take the same pressure from you, applying a pressure to lift this 1 velocity as it takes to lift this 4 velocity. The lever will move exactly the same, so it'll be the same exact motion will create those two circumstances. So if you remove the one of them and just do the 1 mass going 4 velocity, it's going to take the same amount of work to do that as it will take to move the 4 mass 1 velocity. It will feel exactly the same. You won't be able to tell the difference. If I switch those two weights and you can't see that I've switched them, they're going to weigh the same. This will be the same weight as that, even though it's not the same mass, because its weight is really its momentum. Which is another argument about, simple arguments that, this would even be a good experiment. That wouldn't prove kinetic energy. It'd just be a nice experiment for them to do to establish the simple truth of it. That if you took a scale and then you just pushed things into it that have momentum, that is, you just take a mass and a velocity. So you could take an elephant and a velocity and see how much it can compress this scale. Put the elephant on a skateboard or a mouse. And the argument is that the same velocity will produce their gravitational weight. So if I go, I would argue it's 1 mile per hour. So if I move something at 1 mile per hour and I crash it into a scale that's going to absorb its energy, the impulse energy, the mouse will, at 1 mile an hour, will weigh the common weight of a mouse, and an elephant going 1 mile an hour will weigh what elephants usually weigh in gravity. So it's kind of a key point in proving that gravity gives us momentum, that we have actual momentum into the earth at 1 mile an hour is what it comes down to. We can have more if I lift you up and let you fall. Then you can increase your velocity and increase your momentum. But the momentum of you just sitting on the earth is you moving 1 mile an hour. Your mass moving 1 mile an hour. All right, so the other distinct experiment, so the one we're trying to establish is not true, is that if I move the same object, 5 velocity, that somehow that same object, just with 1 velocity, is now 25 times, more powerful. They'll do 25 times the work. So it's a 10 mile an hour thing would do a certain amount of crushing of something. And the claim is that if I make it go 5 velocities, I will do 25 times more, work, 25 times. So, I get a little tiny bit for 10 miles an hour, and I'll get 25 times as much by just increasing the velocity 5, going 50. So they're saying that if you go 50 miles an hour, you're going to use 25 times the gasoline you're going to use if you go 10 miles an hour. And they're saying if you're going 50 miles an hour, you're not going to do 5 times the damage, you're going to do 25 times the damage. And clearly that never happens, never will happen. They'll never be able to show that happening. And that goes back to a ballistic pendulum. And now the other argument is they say that the momentum, so besides saying there's such a thing as kinetic energy, they say that momentum has this catch where somehow if I make something, the bullet go this way, and I make the recoiling gun go that way, that somehow those energies cancel. That somehow I didn't use any energy, or I didn't make any energy, because those two directions are opposite, and therefore one of them has to be unenergy. So they believe you can make essentially free momentum. So it comes down to this simple pendulum experiment you could do, where they claim, I can hit a light thing into a heavy thing, and so I start with 100 momentums in the light thing, swing it into the heavier thing, the 3 mass for example, and I'll get 150 momentums out. That somehow that is possible, and that if these two things, if this did happen, this would swing up with 150, this would swing back with 50, and now I could have a crash between 50 momentums and 150 momentums coming back, and only 100 will pop out. So those are the arguments they're making, is that somehow it's possible to take 200 total motion in the universe and in an elastic collision somehow only produce 100 back out. So no crushing, no deformation, no heat, and yet I converted 200 total motion in the universe into just 100. And the opposite is I start with 100 and somehow I create a 200. I have 150 going that way and 50 going that way. That can't happen. None of this stuff happens. And their physics is based on it. So that's what this is about, is this energy duality. It's real. It's hundreds of years old. It's not been resolved with decisive evidence of any kind. They haven't done any car crashes. They really haven't, like I said, they can't show you a single ballistic pendulum experiment. That is a single experiment where you're taking something that has 25 times or 50 times or a huge amount of extra momentum and absorb it into another object and keep the kinetic energy. So there's no evidence that they ever use the kinetic energy. So something can have 300 kinetic energy, but if its momentum is 10, then that's all it's going to be collected is the momentum, the 10. So it's not a single experiment where they can actually show you this transferring of kinetic energy, where the kinetic energy is actually transferred, actually conserved, because it never is when you bang two unequal masses hit each other in any way have contact with each other, the kinetic energy is never conserved. Now, they claim it is, because they have some little rickety car experiments they do and different things where they don't understand how springs work, and they don't understand angular motion in wheels. They don't understand what a flywheel is, essentially. So lots of, little rickety, grammar school kind of experiments, really poor cereal box kind of experiments. But they have no nice clinical, well-done experiment demonstrating kinetic energy ever being conserved when you're transferring it between uneven masses. And what I'll argue is the classic of the arguments to me. The more you think about it, the more it's just so obvious how this is nonsense. So I have a spaceship in space and I want to move it. If I calculate the KE of this exhaust, the information is absolutely useless. I can't do anything with it. It doesn't mean anything. Because this equal an opposite reaction, in Newtonian terms, I'm throwing away something and I'm going to have to absorb 50% of the action in that event. And the only thing that's going to happen is there's going to be equal momentums. So whatever the thrust is, it's not going to matter what its KE value is, whether I'm throwing bowling balls out of the spaceship or I throw protons out of the spaceship. It doesn't matter what the KE is. It only matters what the momentum is. How much mass is it and how fast is it going? And that's all that's going to decide how far the spaceship, how fast the spaceship moves. So it doesn't work at all in moving stuff in space. And that should be a huge, that should impress people as being, well, gee, that's a pretty big, hard piece of evidence to get past in terms of arguing what use would this silly energy be if I can't transfer it to an object in space, if I can't use it to move something in space. Now, there are idiots who say that Newton somehow believed in it and yet he wrote the third law. And you're saying, come on, it's just so dishonest to sit there and say, well, Newton believed in mv squared because mv squared is never conserved. I'm saying it. It's never conserved. It doesn't matter whether you're going from small objects to big objects or big objects to small objects. You will not conserve the kinetic energy, ever. Unless you're going between the same exact massed objects, kinetic energy will fail to be conserved. And that's the absolute truth we're trying to get to. And the fact is they claim they have experiments that do conserve it. And those are the experiments where I'm describing, where they're creating free momentum. And you can't do that. You can't make free momentum. All right. So let's see if there's anything else. I mean, I've been over this and over this and over this over the last 5 years or whatever it's been. It's just so bad. It's just really bad science, and they should clean it up. All right, so summing up, they're arguing basically, physics argues that it takes 25 times the fuel to make something go 5 times as fast. And I argue that from your own experience that's not true. If I spin a drill, for example, I spin it twice as fast, it's going to use twice the energy, probably a little bit less, not 4 times the energy. I spin it 3 times as fast, it's not going to use 9 times the electricity. It's going to use less than 3 times. 4, it's going to be less than 4, not 16 times. And 5 times as fast is not going to be 25 times as fast. We don't make things very small that spin fast to make energy. We have gigantic windmills, gigantic things spinning very slowly, because it works. It works. There's efficiencies in it because there is no. It's 1 unit of fuel, 1 unit of work. There's no way to make the fuel into more work. It can only do the 1 unit of work for 1 unit of fuel. I can't use 5 units of fuel, make it go faster, and somehow mean that I can make 25 times the work. So again, the simple things, devices prove the point. The lever and other the ones where basically you're saying, look, if you could make an ideal lever, you could actually put the recoil of the gun on one side and the bullet on the other side, and they'll be the same amount of energy. It's they'll oscillate. Yeah. So it's just really bad science, and it shouldn't be defended. Again, the second argument is this idea that because they're trying to force kinetic energy to be conserved, they're claiming, okay, that somehow you can make free momentum, that you can do an experiment, put a certain amount of energy in, and make free extra momentum. And you can't do that either. And it should just be clear, you can't do that. Momentum always works in any circumstance. I don't think anybody can ever point to any experiment that's credible where momentum conservation won't get you the right answer about what's going to happen in an interaction. You just conserve the momentum and you'll get right answers. If you attempt to conserve the kinetic energy, you'll get wrong answers. That's the simple truth, and it should be decisively proven with well done experiments. Probably don't need that. Yeah, I think that was all I had to say. Let me just make sure. Alright, so whether you think I'm right or wrong, you should agree that more evidence is good, that there should be these experiments have done. I mean, we should have dropped the 4 pounds 1 foot and the 1 pound 4 feet. Should have crashed some cars, should have rolled some objects, should have weighed some things, should have caught things with a ballistic pendulum and really measured and see how much heat it creates. If you're going to claim there's 99.94% of the energy is in heat somewhere, well, you should be able to prove that, not just say that. And they haven't done any of it. And it's fundamental to physics. So the sad truth is that all of particle physics, the entire standard model, was built out of 1/2 mv squared. So the kinetic energy theorem is why they invented all of those particles you've heard about. So none of them would exist. Neutrinos, for example, things like that wouldn't exist if it wasn't for the fact that they've exaggerated how much energy is in a system, and so they've had to claim there must be some other carrier that's taking the energy away. And so they invent invisible, funky little particles that they claim exist that must be carrying the energy away. So anyway, so it's ruined physics. A big substantial chunk of physics has been ruined by this pseudoscience garbage that's never been proven with credible experimental evidence. I could go back to 1700s and Chartelet experiments where she dented clay with round objects, and that convinced everybody. And it was really bad science. So again, laughably bad science. The fact that no one's even talked about the fact that you can't do experiments with springs because, in terms of giving objects the same energy, you can't just compress a spring and say no matter what mass I put in front of the spring, it'll leave with the same amount of energy. Because the fact is the speed of the spring is going to matter when the object is released. In the light object, the spring still has a lot of energy. It's still moving very fast when the object you're pushing has left the spring. Therefore, the spring can't possibly give it whatever energy it has left because the object has already left and the spring has plenty of energy left. And it's just a fact that big objects will move slower, that their peak velocity will be slower, so it means the spring will have released most of its energy into the object. And light objects, as you go very light, you won't get anything more in terms of the velocity than the maximum velocity of the spring itself. You can't move something faster than the spring can move. And so it has easily detected flaws where it's not a perfect generator or transmitter of energy. And but the great thing is you can use a spring with a lever and eliminate all of those destructive variables. But they don't choose to do that. They don't choose to do the experiment well and scientifically. And that's bad science when you don't do the experiment scientifically. Okay. All right, so that should be enough. All right, so anyway, even if you hate me, even if you don't think blah blah blah, you should be okay with the idea of encouraging physics channels to do, if they're going to do experiments, to quit doing silly shit like, blowing up bumblebees or something, and actually do some physics experiments. Ones that will prove your physics to be right, your claims about reality to be correct, and such. So, till the next time, and such. Yeah. Thank you if you participated, and if you didn't participate, yeah, get what you deserve. A world full of pseudoscience.